Hello, today we're going to talk about physical and chemical changes. So a physical process is when something changes but the actual chemical identity of the components do not change. So examples of this would be phase changes. So like in this image here, when you're going from a solid ice crystal, it forms this kind of hexagon shape in ice. But when it changes to liquid water and it melts, it's still those water molecules. So each unit is the same, just how they're arranged is different and how fast they're moving is different. This also explains why ice is less dense than liquid water, because it has this kind of open space in there, and that's why ice can float. Don't forget about the other changes of state as well besides melting. So if you're going from a liquid to a gas, that would be vaporization. If you're going from a gas to a liquid, that would be condensation. Liquid to solid would be freezing. And then if you're going directly from a solid to a gas, that's sublimation. If you go from a gas directly to a solid, that would be deposition. Another type of physical process would be separating a mixture. So for example, if you take a mixture here, if the purple substance, whatever that happens to be, has a large enough size in comparison to this kind of greenish colored particle, you could use a filter. And as you pass it through a filter, the larger substance gets stuck on top of the filter, and then the smaller thing passes through the filter. This also works if you have substances that can dissolve in water versus substances that do not dissolve in water. You can pass the aqueous substance through the filter and leave behind the solid substance. Whenever you're filtering, don't forget that your steps here are filter, wash, and then dry. So you want to pass it through the filter as much as possible. Wash it with some additional solvent to make sure all of the filtrate is passed through. And then you'll take this and dry out the substance to make sure any of the solvent evaporates out, and you're left with just your dry solid substance. Now, chemical reactions involve a change in the chemical composition of one or more of the components. So in this case, this is methane reacting with oxygen gas to form carbon dioxide and water. And it's showing the correct mole ratio of those things. We need 2 water molecules and 2 hydrogen molecules for this reaction to balance correctly. The number of atoms should stay the same because of the law of conservation of mass, but how they are arranged is different. So how the atoms are bound together changes. One of the situations that winds up being a little bit ambiguous as to whether it's a chemical change or a physical change is when you take something that is soluble and dissolve it in water. So some people will argue that it's a chemical reaction because the sodium and chlorine are breaking the ionic bonds. But another argument is for that it's a physical change because you can easily get it back to solid sodium chloride by evaporating the water out, and evaporation is a physical change. So it's kind of ambiguous as to whether you would consider it purely a chemical reaction or purely a physical reaction. Maybe it would be some of both. So just be careful when you're talking about dissolving, that you talk about the nuances there.